Hi, a few people in the Notre Dame course have asked me to explain permutations and combinations, as that was done fairly quickly, and a few people struggle with that in the test. So I'm going to put up three, hopefully quick videos just on counting techniques, permutations, and combinations. So probability is all about counting. Um, the formula for a probability is the number of favorable outcomes over the total number of outcomes. So an example of this is, what is the probability of rolling a 3 when rolling a 20-sided dice? The multiples of 3 are 3, 6, 9, 12, 15, and 18. So there are 6 favorable outcomes. And there are 20 different things that can occur. Therefore, the probability of rolling a multiple of 3 is just 6 out of 20. Now, that is a fairly simple, nice, easy, hopefully, example. So it becomes very important to be able to count how many different things can happen, and this can become extremely difficult very quickly, and therefore we need some rules. Let's go through this example. How many different number plates are there of the form letter, 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 number, number, number? Now, to count all the different ways this can happen, we look at each individual thing. The first letter can occur in 26 different ways. The second letter, another 26 different ways. The third letter, 26 different ways. And the numbers, they can occur in 10 different ways, 0 to 9. The second number, 0 to 9, so 10 different ways. And the third, 10 different ways. So the total number of different number plates of letter, 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 number, number, number is just this formula down here. 26 times 26 times 26 times 10 times 10 times 10, which is 17,576,000. Let's look at another example similar to this. What is the probability that my number plate will start with an A and end with a 6? That is, we'll have the form A, then letter, letter, number, number, then 6. So there's a few examples there. Now, we've counted the total number. Remember, probability is the favorable outcomes over the total outcomes. From example 1, we've already counted the favorable outcomes over here, 17,576,000. So we need to count the number of ways an A can be first and a 6 can be second. So the first letter only has one chance. It's only one different thing can happen. Then the second letter can be 26 different things. The third letter, 26. The first number can be 10 different things, then 10 different things. Then it has to end in the 6. There's only one way. So the number of favorable outcomes is just 1 times 26 times 26 times 10 times 10 times 1. So there are 67,600 different number plates of that form. And that's the simple probability, the 67,600 over the 17,576,000. And yes, you should simplify that, but I've just left it like that. And the last example, what is the probability that my number plate will have 3 different letters and 3 different numbers? So here's the solution. We counted the total number, 17,576,000. We now need to count the number of ways three different letters and 3 different numbers can occur. Now, this is starting to get into some sort of permutations and combinations, but we'll do it in a nice, simple way. How many different letters can be the first letter? There are 26 different letters. But once we've chosen that first letter, there's only 25 different letters for the second. Then only 24 different letters for the third. Once we've chosen the first number, there are 10 different ways to do that. The second number can occur in 9 ways. Then the third number, 2 numbers have already been selected. There's only 8 different numbers you can choose. So the number of favorable outcomes is just 26 times 25 times 24 times 10 times 9 times 8. So 11,232,000. Therefore, the probability, number of favorable outcomes over number of possible outcomes. I hope that's helped a little bit. That's the first little one. Thanks.